Uh, Good morning, everybody. I am Intissar Ghaffar from University of Boumerdès, Algeria. My presentation is about the effects of trauma on Varroa lifespan in resistant colonies. Some honeybee population in Algeria have developed resistance to Varroa mite. Dadon et al. 2020 showed that the grooming behavior in our resistant colonies is more pronounced than in susceptible colonies. It was also shown that this grooming behavior does not cause injury to the Varroa. The same results have been obtained by other studies. All these studies have shown that grooming behavior does not cause injury to Varroa. So, observations of an valuable tool, which is the inserts on our resistant colonies, have shown an overmortality of Varroa. Our hypothesis is that these bees that are grooming themselves, even if they are not the cause of these injuries, by removing the Varroa, they can provoke a trauma that would be the cause of these mortalities. So, to confirm this hypothesis, we repeated the same experiment done by Dadon et al., but we took into account the mortality that would be due to the shock caused by the grooming. The Petri dish, as you see, test was carried out according to the method described by Omer. 122 Varroa were inoculated at the rate of 1 individual per trio. The 46% Varroa removed by grooming were individually placed with a food source in artificial cups to simulate a natural worker cell. The artificial cups, artificial caps were kept at room temperature and protected from light. Varroa in these caps were monitored every 30 minutes to record their lifespan. The results obtained showed a decrease of about 37% in the lifespan of the removed Varroa compared to a control composed of healthy Varroa that were neither exposed to a stress situation nor the aggressions. The difference was significant. If the adult bee does not cause injury to the Varroa by grooming behavior, it suggests that when the Varroa passes from one worker to another, the parasite would pass through the legs of the workers. It's possible that during this passage, the Varroa is trapped, and by friction between the legs of the worker, it would cause injury or trauma to the Varroa. To test this hypothesis, we put workers individually in Petri dishes. Then we inoculated each one with a Varroa on one of the hind legs. After a waiting time estimated at 10 minutes, of the 29% Varroa removed by the workers, no injuries were recorded. The lifespan measurements was made using the same protocol as for Varroa mites removed by grooming. So the results obtained showed a decrease of about 41% in the lifespan of Varroa removed by friction. The difference was also significant. These results showed that the action of removing the Varroa by grooming or friction did not cause injury to the parasites. On the other hand, we had recorded a decrease in the lifespan of removed Varroa. However, the overmortality of the Varroa observed on the inserts would be due to grooming behavior or the friction. Now I return. Now I return to the inserts where we found over mortality and injuries. The over mortality, as we have already seen, could have two origins: grooming or frictions. But we have not shown that the adult worker can cause injuries to the varroa. So what could be the cause behind that? Would the brood play a role in these injuries? How can the brood be the cause of varroa injuries? Maybe the pupa, hindered by the presence of the varroa, it moves in an abnormal way, which would cause injuries to parasites. Before continuing, I want to show you what I mean by injured varroa. Injured varroa are defined as mutilated varroa, with one or more legs cut off or totally torn off, or varroa with damaged mites. I point out that the parasites that reported by Davis with one or two diagonal dimples symmetrically positioned on the back of the idiosoma are not counted as injured individuals. Therefore, in order to study the involvement of the brood in the injured observed on the varroa, we observe them in natural form in vitro, in total absence of adult bees. For that, we put brood at an advanced stage of development in wooden cages. White absorbent paper was placed at the bottom of the wooden cages under the frames to cushion the impact of the falling mites. We proceeded to the separation of the emerging workers and the recovering of the varroa in natural form every 30 minutes. We found that despite the absence of older workers and in the absence of brood only, we observed injured varroa on these inserts. Approximately 26% of the varroa found at the bottom of the wooden cages were injured. These observations lead us to put forward three hypotheses on the cause of these injuries. The first one, as already mentioned, it's possible that the imago in the brood moves during the last hours before its emergence would cause injuries to the parasites. To test this hypothesis, we did this experiment as follows. We took a frame of late-stage brood, opened the cells, and observed see if there are injured varroa inside these cells. 3 varroa mites only were found injured and alive inside these cells. I specify that these mites were recovered from the over-infested cells. The involvement of the brood in varroa injuries is not yet confirmed because of the insufficient number of varroa found injured. So we cannot draw definitive conclusions. The second hypothesis, the few varroa injured in the cells may already be injured before their introduction in the brood. To verify this hypothesis, we proceeded to the mutilation. Next slide. The mutilation of one of the legs of 67 varroa, then the mutilated Varroa mites were put individually with a food source to monitor their lifespan. The results show that a mutilated Varroa mite cannot live more than 4 hours. It's therefore impossible for a mutilated Varroa mite to have entered the brood and remained alive during the whole pupal stage. We have observed in natural conditions fighting of Varroa on the inserts. These observations lead us to put forward the third hypothesis. It's that the Varroa also fight in the cells, and this is the origin of these injuries. We are going to verify this hypothesis under controlled conditions. I come back to the experiment. So to test the third hypothesis, in a petri dish, we put 3 artificial cups. In each cup, we put 2 healthy Varroa. And we observed for a while if they fight and if this fight results in injuries. A contact time of 1 minute, 2 minutes, and 30 minutes results in no injuries. On the other hand, we observe injuries Varroa only in the individuals left for an indeterminate time. We had 7 injured Varroa, or 5%. Based on these experiments, we would conclude that the mortality would be due to grooming behavior and friction between the legs of the bee. For the injured Varroa, with a great caution, the hypothesis was put forward that the Varroa's fight between themselves could be one of the cause of these injuries. We do not know the causes of this fight. Is that a behavioral disorder, which could be due to a substance emitted by the resistant colonies, which would excite the Varroa and make them aggressive between them? Or is that a way to regulate the rates of parasitism in these resistant colonies? Finally, it's necessary to look at the Varroa relationship in resistant colonies. I hope you enjoyed this presentation. Thank you for your attention.